So here's a thought. What if a computer could diagnose the flu better than your doctor? It's a question that could totally change your next trip to the clinic. Today, we're going to dive into whether AI can finally solve one of the most common puzzles in medicine.
Oh man, we've all been there, right? You wake up feeling just awful. You've got the fever, the cough, the aches, that miserable trifecta. And you're thinking, it's probably the flu. But is it? Or is it one of a dozen other bugs going around? That uncertainty, that's right where our story starts.
And that uncertainty, it has some pretty huge consequences. One study found that over 60% of patients who are later confirmed to have the flu don't actually get the right antiviral medicine at first. That's more than half. It's a massive, massive diagnostic gap.
Okay, so what's the deal? Why is this seemingly simple question, do I have the flu, so incredibly tough for doctors to answer with certainty? Well, this gets us to the heart of the problem.
Here's the biggest hurdle. The flu is a total master of disguise. It's a chameleon. The symptoms are so general, they look just like countless other illnesses. This makes trying to diagnose it based on symptoms alone a real challenge, even for the most experienced doctors out there. And here's why getting it right and getting it right fast is so important. You see, those antiviral drugs, they're most effective when you start them within the first 48 hours. After that 2-day window, their power really starts to drop off. The clock is literally ticking from the second you start to feel sick.
Right, so that ticking clock, it's a huge motivator to find a better way. It's why researchers are desperately searching for a more reliable method. So let's look at the tools we have now and see why they're just not cutting it.
So right now, we basically rely on two things. First, there's the doctor's own clinical judgment, their experience, their gut feeling, and that's super valuable, but it's not foolproof. Then you have these older computer models, but honestly, their performance is all over the place, wildly inconsistent.
And get this, what about those rapid tests, right? The ones you get at the clinic? Well, it turns out even the CDC is saying, you know what, we don't recommend those anymore. Why? Because their sensitivity is just too low. They miss way, way too many real flu cases. So that leaves a huge opening for a brand new approach.
Okay, so if a doctor's intuition isn't quite enough and our old tech is unreliable, where do we go from here? Well, researchers had a big idea. Let's bring in the AI. Let's see if we can train a machine to become a world-class flu detective.
So hold on, what even is machine learning? Let's break it down. Imagine you're training a new medical student. You don't just give them a rule book. You show them thousands and thousands of real patient cases. They see who had the flu, who didn't, and over time, they learn to spot the subtle patterns. That's exactly what we're doing here, but with a computer.
Now, to train an AI student like this, you need a textbook, a massive one. And that textbook is data. A lot of data. For this project, researchers gathered incredibly detailed information from over 2,000 patients with flu-like symptoms from both the United States and Taiwan. That created this really rich, diverse data set for the AI to learn from. What the scientists did next was pretty cool. They basically set up an AI Olympics. They didn't just bet on one horse. Nope, they took 7 different AI algorithms, let them all loose on the same massive patient data set, and then watched to see which one would come out on top.
All right, the moment of truth. After all that training, after that big competition, how did these AI models actually do? Did they pass the test? Let's check out the scorecard. And folks, it wasn't even close. There was a clear runaway winner, an algorithm called XGBoost. The way it works is kind of like having a whole panel of AI experts who all review the case and then they all vote on the final diagnosis. It's super, super powerful stuff. Okay, take a look at this chart. See that bold red line way up at the top left? That is our champion, XGBoost. And all those other dotted lines lagging way behind, those are the older models. I mean, you don't have to be a data scientist to see that performance gap. It is just huge. And if the picture isn't enough, let's talk numbers. This XGBoost model scored a 0.82 for accuracy. Compare that to the older models, they were all stuck down in the low 0.6s. That is not just a little bit better, that is a night and day difference, a total game changer. But check this out, this might be the most important number of all. 92%. What does that actually mean? It means the AI correctly identified 92 out of every 100 patients who truly had the flu. It's just incredibly good at catching the real cases and not letting them slip through the cracks.
Okay, this is amazing, but it kind of feels like magic, right? So the big question is, what did the AI actually learn? What signs was it picking up on that we were missing? Let's try and peek inside its brain.
Now, this chart looks a little complicated, but the idea behind it is pretty simple. It's basically a ranked list of the most important clues the AI used. The stuff at the very top had the biggest impact. If you see red dots pushing to the right, that's the AI giving a big thumbs up for it's probably the flu. Blue dots to the left, that's a thumbs down.
So what's the bottom line? The AI figured out that a high temperature, a cough, a runny nose, and knowing you were recently around someone with the flu, those are all huge red flags. But on the flip side, if someone's been sick for several days, or they just got their flu shot, the AI learned to think, probably not the flu. It learned what to look for, and just as importantly, what not to. And here's the best part. This isn't just some theoretical research paper sitting on a shelf somewhere. The team actually turned their winning model into a simple web tool. A doctor can literally just plug in a patient's info and get an instant AI-powered probability score. It's taking this amazing tech out of the lab and putting it right into the doctor's office. Which brings us all the way back to the beginning. What we're seeing here is a glimpse into the future. A future where AI isn't about replacing doctors, but about giving them superpowers. Giving them incredibly accurate tools to help all of us. So we'll just leave you with this to think about. In a world with tools this powerful, what does the future of a simple diagnosis look like to you?